All right. Hello, everyone. Good morning. How's everybody doing? Great. Did you all get your coffee, breakfast, all feeling energized to start your day today? Awesome, awesome. All right, so let's get started. I hope you're all excited to learn something about block storage today and probably familiar with it as well. Awesome. So I'll introduce myself. My name is Reena Gupta, and I'm a product manager in the EC2 storage team. And with me is my colleague, Aaron Chen.
Hi, everyone. My name is Aaron Chen. I work with Amazon EBS team as a product manager.
Nice. So Aaron will be joining me later for in between when we'll do a little bit more. He's going to talk about the EBS, and I'll start off.
Right.
Thank you, Aaron.
See you guys in the lead.
All right. So I hope you wanted to know more about block storage and how do we choose the right block storage for your business. And our goal for today is to get you set up to make that choice very clear. And just like a real world, the physical storage unit concept that you might be familiar with when you rent it out, and similar to that, Amazon EC2 also offers the multiple choices for compute and storage in the cloud. This is very similar kind of analogy there. And in the session today, we are going to first talk about you as customers and your workload requirements, what we hear from you. Following that, I'll give you an overview of what all different choices Amazon EC2 has to offer. We'll go over some of those different choices. We'll give you a bit of an overview and a bit of a knowledge about each one of them. Hopefully, you'll be familiar with that already, but we'll just give you an overview to just get started, give you knowledge and information about each one of those, and then we'll give you the right guidelines to navigate your path among all these storage choices, how to choose the right one for your business. And then after that, we'll walk you through with real customer examples, how did they go about choosing the block storage solution for them. So in this fast-paced digital era, almost everything that we do in our lives, everything is generating loads and loads of data, petabytes and petabytes of data. And that usually involves some sort of data management, data processing, data analytics going on. And some of these use cases, they handle the data real time as it's ingested. And what you see here today, in this landscape, there are a couple of industries, couple of workloads and applications that I'm showing up here. That's something we usually come across on a daily basis. And some of these applications, when they ingest the data real time, they really require the data to be retrieved from the storage very fast. And that's when we are really looking at what is the right block storage choice for these kind of workloads. Some of the common ones that you see up here are the databases, the analytics, the search indexes, and so on. And hopefully you also see some familiar applications here. Any of you see some of the familiar applications that you're using? Awesome. Hopefully, you are covering a good landscape here, but anything we're missing, of course, that's something we want to learn from you as well. Now, let me talk about, with those applications of workloads in mind, what we have been hearing from our customers. These are some of the real customer examples, what they have told us about their requirements. Some of the customers have the random IOPS, really high throughput, as top of their mind. And some of them have very latency sensitive workload, and they really care about some millisecond kind of latency. While others have mission critical data that they want the data persistence for that kind of storage, and they want data to be staying with them across any AZ failure type of events. And while the others, they also want to do regular backups to keep a copy of their data. And that's why they want to make sure that whatever block storage solution they're going to be looking for, that's the right one, and that gives them all the things that they are looking for. And while I showed these examples, I'll actually go over some of these examples towards the end of the presentation to really give you an idea about what did they do for their needs and what did they actually end up picking. So that kind of customer examples and the feedback that you saw earlier, we generally hear lots of those, and over many years, AWS has heard all these feedbacks and the requirements from our customers, and that's how we continued on that path of innovation, and we have been trying to cater to the customer needs. And as a result, Amazon EC2 now has over 650 instance types with different compute, memory, and storage specifications. And not just that, we also have multiple block storage offerings. So now the question comes up, which one is the right one for my business? Does this question come up to you as well, majority of the time? And this is where we are trying to help today. So this is the goal for today's session, that you walk away with the guideline in terms of a flowchart approach to see how do I navigate, what is my requirement, and based on that, what block storage is right for me. So let's deep dive into it. So first of all, let me just go over what type of storage solution Amazon EC2 has to offer. And depending on your workload, whether you have block, file, or object storage, or you need backups, there are different types of storage solutions that AWS offers. For your block storage, we got two types of solutions out there. One is the local instance store, other one is the Amazon EBS. And here in the local instance store, you have the data, the storage locally attached to the instance, whereas the EBS is attached over the network. Similar to that, if you have the data in the object format, and the object format is where, generally speaking, you have lots and lots of dense data need, that's when Amazon S3 type of storage will work for you. And if your data, your workload, is actually working in a hierarchical file format, that's when Amazon EFS, which is Elastic File System, or FSx will be the right choice for you. And then on top of that, we got backup solution as EBS snapshots or AWS backup to cover for all of these storage solutions that you have here. But for today's session, what we're going to be focusing on is especially on the block storage side. What you see on the right side is the local instance store and Amazon EBS. So just speaking of the block storage options on Amazon EC2, there are, again, I'll keep diving further and further. So what we have on the local instance store choices is the iFamily instances and the CMR instances. iFamily instance is very specifically optimized for storage workloads. That's why we also call them storage optimized. This is what you will see on the website as storage optimized instances in the categories. The storage optimized instances, they have much denser storage attached to it, everything in the form of locally attached NVMe storage, but also they are storage optimized because of the Nitro SSDs attached to it, and I'll talk about that in a bit. And these instances, you may want to think about, since it's denser storage, if you have any workloads which do have very dense storage needs, that's when you would need these iFamily instances. Plus, because these are very specifically meant for storage-intensive workload, that's when you would need this. And also, these workloads are latency sensitive. On the CMR disk instances, this is where there is small amount of storage attached to the instance, which is up to 7.6 terabyte. And specifically, the CMR disk instances are good for caching or scratch space or the temp logs type of workload, or sometimes even for very small database needs. Now, both of these, because they are local, they have the local attached NVMe SSDs, they both delivered millions of IOPS. So performance is the key thing for local attached NVMe SSDs when you need millions of IOPS. That's just one thing to understand about local instance store. On the other hand, we have Elastic Block Store, which is also very flexible storage given to you, and it is connected over the network. And for EBS, Aaron will go deeper dive into it, and you'll hear more from him. Now let me talk about the storage optimized instances. First of all, let's understand what is the storage optimized instances. Why do we call them storage optimized? These are designed for very specifically storage intensive workload, very specifically. And that's when we talk about storage intensive, as we saw earlier, the databases or the analytics where you have deep storage need, and they are very careful and very sensitive about the latencies. These workloads are also asking for very tight and very high frequent read-write access going on with the data storage. The storage optimized instances are optimized to deliver millions of IOPS, and what I'm talking about here is in terms of 3.2 million IOPS per instance. That's the limit it can go up to. And when we speak about the latencies, since these are storage optimized and they are working with the Nitro SSDs behind the scene, they are optimized to deliver very low latency and consistent latency, which I mean by reducing the latency variability. That's what these instances are meant for. And that's when these applications, when they have very stringent SLA, these instances will definitely help you. So speaking of the storage optimized instances, let's go over the portfolio. So within the storage optimized family, we got 5 different types of instances. And they are all, again, categorized between 2 categories. One is a best performance category among the I instances. The other one is a low cost per terabyte. So the best performance category has I4I and I4G. I4I is Intel-based, and I4G is Graviton2-based. I4G is actually fairly new. We recently launched it earlier this year. And in the low cost per terabyte category, we got i3N, which is Intel-based, and IM4G and IS4GN, which are Graviton2-based. These low-cost terabyte instances are much denser. They have more capacity per vCPU compared to the best performance instances. So you get the best performance instances, you get more performance per vCPU and per terabyte of storage. That's when they deliver the best compute and the best storage performance for your workloads. And our goal is actually to offer you the different choices across different processor choices, Intel and Graviton, so that you get an optimized instance for not just for performance, but also for cost and power. And you probably already been hearing so far, Graviton-based instances, they deliver efficiency in terms of performance. You get the best price performance as well as you get best power efficiency. So just going deeper into the storage optimized portfolio, this is to give you an idea about how do they compare with each other, what type of spec these instances carry. In the performance category, you will notice here that both I4I and I4G have the same vCPU to memory and same vCPU to the storage ratio. But what's the difference? I4G is Graviton2-based and delivers better compute performance, better price performance than the I4I. It's 15% faster compute performance than I4I. On the low cost per terabyte, you will see that there are all these instances, they vary in vCPU to memory and vCPU to the storage ratio. So as we go from left to right, you will notice that the storage density is increasing, and so is the cost per terabyte is decreasing from right to left. Yeah, okay. Right, so this is to just give you an idea. You might see the pricing on the instances in the low cost per terabyte is increasing when you look at it on the website, but the actual dollar per terabyte, that's not something you easily see. But when you calculate it, dollar per terabyte becomes lower because you get way more storage on a per vCPU basis. So there are different use cases for these, each one of these instances, and when you would use them and which one would you use them. There is another chalk talk that I'll be doing this afternoon. We'll be going much deeper into how to really use these instances in what type of cluster scenarios. We'll go over multiple of those scenarios. So feel free to join me this afternoon at 3 o'clock we'll be going over that. Now let me unpack a little bit more behind the storage optimized instances. What is the power behind it which is delivering that performance and which is delivering and making them storage optimized instances, which is Nitro SSDs. Pretty much majority of the I family instances are backed by Nitro SSDs. The primary feedback that we have heard from our customers about their storage intensive workload is many of times they're running the real-time applications. And these applications require very high performance. And they want predictable latency. They want high performance for a given latency, and they don't want the latency to be varying as much. That's when they call it tail latency. They want reduced tail latency. And they want best performance for their database workloads. As well as they wanted the storage to be more reliable and high quality. So continuing on that journey of innovation, AWS came up with Nitro SSDs, Nitro systems, and then with Nitro SSDs. And we launched the whole 4th generation family of I instances that we saw earlier with Nitro SSDs. And that's what is differentiating a little bit from the CMR disk-based instances, because Nitro SSDs are only available with the storage optimized instance so far, not with the CMRD instances right now. And what you see, the Nitro SSDs, because they are designed by us, they are very much controlled and managed by us, we are able to improve your workload performance by reducing the latency by up to 60%, and reducing the tail latency, which we also call the spikes, by reducing them by up to 75% compared to the previous generation instances. And last year, we also launched another feature which is tightly integrated with Nitro SSDs called torn write prevention. What it does, it eliminates the need for the double write buffer for relational databases like MariaDB or MySQL, and thereby improves the performance of the database workloads transaction per second by up to 30%. And since these are designed by us, we are also able to manage the Nitro SSD's firmware updates. We are able to manage and improve the operational efficiency, the debuggability, as well as the telemetry by rolling out all these updates at the cloud speed and at the cloud scale, which is very important differentiation when we compare these to the regular commercial NVMe SSDs. Now let's understand how do these Nitro SSDs help with the real-time data processing type of workloads, which I've been majority of the time I'll be saying real-time data processing, because these applications, as I said earlier, they're requiring really fast access from the storage. They want the response in real time. I'm talking about microsecond level. That's super fast. Like you blink and the data is there. And these SSDs are delivering that consistent performance at the petabyte scale. And because of the predictable performance requirement from real-time workloads, the Nitro SSD is able to deliver that predictable performance because it's always going to be consistent. You can definitely rely on it that my data, if I need this level of millisecond, this is my SLA, I'm going to be completing the workload data response, it's going to deliver that in that real time. And along with that, all the read-write and high-frequency performance that's going on, many times it's not just the real-time workloads, but also the non-real-time workloads are running together. And the Nitro SSD will deliver the similar performance for both of those. And of course, as we talked about earlier, the low latency variability is reduced by up to 75%. That's how we meet the real-time data processing needs. And I wanted to bring up an example. Built on the Nitro SSD foundation, ScalaDB customer, they observed twice as much performance 40% reduced latency, and 30% better price performance compared to the previous generation instances. And this was with the EC2 i4i instance. They adopted this instance to boost the performance of their ScalaDB cloud. And this is just one example. And I'm talking about the real-time databases here, ScalaDB, Redis, Aerospike. There are a bunch of these real-time database examples that i4i is excellent choice for that workload. Now, another thing I wanted to bring your attention to, a very important point here, is about the data persistency on local instance store. Many times this question comes up, under what scenario the local instance store actually persists data? Do they actually even persist the data? It does. They do. So what are those scenarios? So first thing to understand is the instance store data is persisted during the lifespan of the instance. And what are those scenarios? When you're rebooting, power cycling, restarting the OS, or even if you are creating an instance store backed AMI bundle that is going to S3, the data will be carried over. Sometimes we have heard from our customers when they are testing the instances and they're concerned, is my data going to persist? It will, because they're just power cycling it. That's fine. But there are other scenarios where the data does not persist, because that's how the local instance stores are designed. And those scenarios are when you're stopping, terminating, or hibernating, or instance retirement events. During those events, the data won't be persisted, or the instance type is changed, or when you're creating a Windows or the EBS-backed AMI, the data is not carried over. And of course, if there is an underlying SSD failure, that data won't be available either. Now, what do you do in those scenarios? You want to use instance store for your real-time applications, the database type of workloads, and database is the sweet spot, I should say. What do? You either do, let's say, increase the resiliency of the instances by replicating the data over clustered scenarios, or you can have another instance across AZ. You can have those clustered as well. Then the other option is you can make a copy of this data to more reliable storage like Amazon EBS or S3. And then speaking of the data persistency, let me bring over Aaron, and Aaron is going to talk more about the Amazon EBS.
Thank you, Rena. So now you have heard about Amazon block storage two choices, instance store and EBS. So let's talk a little bit about EBS. So quick show of hands, how many of you have used EBS before? I see many. Actually, quite a few. You're right. Because chances are, if you have launched Amazon EC2 instances, you have used EBS, because EBS is the boot volume for EC2 instances. So instance store, what Rena talked about, is directly attached raw disk, local to your instances and offering block storage with very, very high performance. EBS is different here. It is a large distributed block storage system offering you high performance, highly available, and highly durable. So pairing with different EC2 instances, you can run into any workload at any scale. So there are different EBS block storage products I'll talk about in a bit, and pairing that with different EC2 instances. And important part here is, as the EBS volume is attached over the network of EC2 instance, it persists beyond the instance lifecycle. This is a different part from Amazon EC2 instance store. So with that, you are able to stop the instance or start again. Or you detach the EBS block device and attach it to another instance. Or you can even terminate your instance. Your data is still going to be there along with your volume, unless you explicitly tell it to delete. The most important thing to remember here is that an EBS block device or EBS volume is not just a disk. Like I said, it's a distributed block storage system. your data stored there is sharded across multiple storage components to provide you durability. So as you see in a bit, in this way is how we design and how we build EBS, and this is how we deliver new features and functionalities. So I talked a little bit about different volume types. What are they? Broadly, two categories. You have SSD, solid-state drive, and then you have HDD, hard disk drive. Under the SSD category, we have general purpose, represented by GP3, which is a crowd favorite. It strikes a balance between the price and the performance and suitable for most of your workloads. We also have provisioned IOPS category, represented by IO2 Block Express. This is for your most mission-critical, performance-sensitive workloads. And on the right-hand side, you can see we have HDD product, ST1 and SC1. These offerings are lower cost and provided you support for more throughput-focused workloads or lower frequently accessed workloads. All right. I want to stay on the point of the volume type, which is provisioned IOPS. Some of you may have used IO1, or have you heard IO2 Block Express. These are the volumes designed for your mission-critical latency and performance-sensitive workloads, such as Oracle Database, SAP HANA, SQL Server. With those applications, you require highly durable, highly available, and high-performance, low-latency block storage. And a few years ago, we launched a product called IO2 Block Express just for that. IO2 Block Express started with supporting one instance back in 2020, and that is EC2 R5B instance. Along the way, we have gradually added more supported instances, and about 2 months ago, it supported across 20 different instances. Well, if you have been to one of our leadership innovation sessions, you would have known that right before reInvent, we broadened the support scope. Now, all the EC2 Nitro instances support the EBS IO2 Block Express volumes. What does that really mean? Well, if today you start provision and launch a new IO2 volume, it will have been running on the Block Express architecture and provide you high performance and low latency. So with IO2 Block Express now, you can achieve sub-millisecond latency, and for a single volume, you can provision up to 256,000 IOPS, 4 gigabytes of throughput, 4 gigabytes per second throughput, and up to 64 terabytes of capacity. These are all much higher than our earlier generation of IO1 volumes. Let's look at a little bit more on the specs. Right? So here's a few key factors that are different. Again, if you are more sensitive to the performance, SSD are the products that are right for you, especially if your workload requires flexibility in provisioning IOPS and throughput. GP3 could satisfy most of your needs because it's flexible and it supports provisioning up to 16,000 IOPS per volume or 1,000 megabytes per second. Do run your mission-critical workloads on IO2 Block Express, which has a much higher performance, sub-millisecond latency, and what is more important, 5 nines durability. This is crucial for a mission-critical databases. On the right-hand side, HDD products offer high throughput but low IOPS. These are mostly for your throughput needs and consecutive IOs as your hard disk. Right? If you have data warehouses, streaming workloads with large throughput needs and consecutive IOs, these would be the good choices for your product. Now, we talk about volumes. Beyond the volume type offerings and the performance, EBS has additional features. One of the most important ones is EBS snapshots. So what is snapshots? These are point-in-time data copies from your EBS volume to Amazon S3, which offers high durability. Initially, we launched this product in 2008, and it's meant to provide a simple and cost-effective way of backing up your EBS volumes and your data. But along the way, we hear feedback from you guys. There are more use cases now supporting by the snapshot than before. The use cases evolved. Now customers are using EBS snapshots to share Amazon machine images, or AMIs. These are backed by EBS snapshots, and customers use it to update their instances and operating systems across the account or across the region. Also, customers started to copy the snapshot to different regions for disaster recovery and protect against the ransomware into different regions or into different accounts. But these things, you can't always manually manage your snapshot. So we also have Amazon Data Lifecycle Manager, or DLM. These, you can create lifecycle policy for your Amazon resources, such as EBS snapshots here, like creating a snapshot or keep a retention policy, so that way your workflow are all automated. You can also create policies for your EC2 instances targeting that to create EBS-backed armies. So snapshot is a great feature, but it's not the only feature. What about when my workflow needs the data to flow and move around? What if I want more scalability and predictability? So for EBS volumes, one of the common asks is, I want to make it easier for me to start with provisioning a volume. I might get it wrong, but I started with a parameter. And then later, I want to be able to change that volume. Or I have a volume, but then as customer workloads grow, I want to be able to scale. So elastic volume, or EV, is the feature designed just for that. If you want to increase capacity or scale your performance up and down, or even if you want to change volume types to meet your different block storage needs, it will be done by EV seamlessly. What I mean by that, zero disruption to your workloads. It is an online operation. When you do an EV, all while your application is running. You will not have any downtime. Now, we launched another thing called Fast Snapshot Restore. This is to address another very important issue for the customer. It removes the impact of volume initialization. So when you restore or launch a volume from an EBS snapshot, because this data is stored in Amazon S3 on the snapshot, and when you create a volume, the data needs to transfer from S3 to EBS. When you have that, but if you start your application on EBS, if you are trying to retrieve a data that is not yet on the volume will retrieve it from the S3. And that adds a little bit of latency and can impact your application if it is very latency sensitive. So what do? Well, initialization is there, but we launched Fast Snapshot Restore to remove the impact of that. So when that is enabled, if you create a snapshot with FSR enabled, as soon as you provision a volume based on that, your volume will be fully performant. You don't have to wait for your data to populate. This is great for under extreme need for your data recovery scenarios, that if you have a situation on one of your volumes, you can spin up another one immediately with full performance. Now, let's look at a customer example, how they utilize all these features and EBS performance. So let's take a look at Cox Automotive. So they are running their mission-critical workloads on EBS, EC2 and EBS now. They migrated their on-premise Oracle workloads to us to take advantage of the simplicity and scalability of the cloud. So the Oracle workload here they are using requires sub-millisecond latency and high resilient cloud infrastructure. So the choice here is EBS IO2 Block Express. So with that, it provides them sub-millisecond latency. And pairing with a few different EC2 instances, they are able to run 210,000 IOPS in the cloud. Together, Cox Automotive was successfully running their Oracle database with up to 50% improved performance compared to on-prem. What is more, for their resilience need, Cox Automotive use automation to take EBS snapshots, protecting their data. They take 3 snapshots per day and have a 7-day retention policy for meeting their data protection and also backup compliance needs. So I've talked about EBS. You have heard it from Rena about Instant Store. Now come back to the main question. These are the 2 categories. How do you choose your block storage solution? I wish there's a simple answer, but the answer is it depends. Right? We can't tell you to go with one or the other. The answer lies in the key of your workload, your performance needs. It lies in the details. So how do we do here? The way to simplify this process is by answering these questions. If you're able to think through these questions and answer most of them, it will guide you to your right solution. We start with identifying your workload. That will give you an idea of broadly which block storage to choose. And then it is important to think about your performance needs. That means your throughput needs, your IOPS needs, your latency needs. Your next consideration should be your data persistency, durability, and high availability needs. Then followed by, how do I think about my data protection and other features? And of course, don't forget to price the solution to calculate your total cost of ownership when you run your application with both EC2 and EBS. Well, let's unpack that a little bit more, starting from the first question. First, what is your workload? Do you have a database? Is it streaming? Is it a tier 1 service that is super critical, you can't afford to be down in even 1 split of a second? Or everything else? It is possible that different storage solutions all can satisfy your needs, but knowing your workload and knowing some basic matchings, this can give you some direction. For example, you can run your relation database, virtual desktop, if you have a secondary environment running your test and dev, or if you simply need a boot volume. You can run them on GP3. It's a good choice. And as I talked about before, when you have a mission-critical, IO-sensitive, your relational database or non-SQL database needs, IO2 Block Express could be helping. And if you have real-time analytics or real-time database needs, when your latency is so sensitive at the microsecond level, and you are running this with dense storage, go with the iFamily. If you're running some smaller databases or web app or caching, you have a series of core CMR instances along with their disk variant that is labeled by a lowercase d. So now you know your workload, and you have a basic sense of, OK, where am I going? Then you can use this flowchart to help you further navigate down the path to the right block storage. So we start from the left. First step is, what is your performance requirement? Okay. Do you have a very sensitive need in terms of latency that is real time? And do you need 1 million IOPS? If that's the case, go with Instant Store. If you need sub-millisecond level latency, or even single-digit millisecond latency, and if your IOPS needs is below 400,000, you can use EBS. The next step is to talk about data resiliency. If your workload is mostly stateless, you don't need your data to persist beyond your instance lifecycle. You terminate your instance, you don't need to save your data, poof, it's gone, right? If that's the case, Instant Store can be your choice. However, if you do need to persist your data, and you do need the volume to attach to different instances later, or if you want durability and availability, but you do not want to manage it yourself, then EBS would be in a good place. So next, your feature and capacity. Do you want to self-manage your backup, moving data over the network to S3? Or do you want to use the native integrated solution like EBS snapshots? Do you have a strong scaling needs that you adjust performance so ever often that you want to use elastic volume? Or you can choose to spin up a new node and do scale out. Those would guide you to EBS or Instant Store. So at this point, after answering all these questions, you probably are already leaning towards one solution or the other. And then it is time to use AWS pricing calculator to estimate your total cost of ownership. So with that, let's take a look at some examples to bring it to real life. With that, I'll hand back to Rena.
Thank you, Aaron. All right, let's take a look at some real examples. Remember the one that we showed you earlier in the beginning? So I'm going to just bring back a few examples from that slide. So this example is a customer, which is a social media company. And they ingest data from the live streams, and they generate logs. Their application requires really high compute performance. They process very high frequency of the read-write requests, and especially very high random read-write IOs. And they are very sensitive to latency as well. Pretty much real-time workload going on here. Their workloads, what they have defined, are the RocksDB and the Druid databases. And many times we are noticing that this is NoSQL type of databases which are coming into play. So now, the requirements are very clear. Large amount of random IOs going on, sensitive to latency, need very fast compute, and they are really, what they are also doing is they are processing these logs and these live streams in a local attached storage. But that's their use case. They are doing lots of processing in the local attached storage, and then they're moving the data off of to some other network attached storage. So here for their scenarios, the EC2 I4I or I4G, both of those instances work for them because they really want the best compute performance, they want the best storage performance. That works for them. And when part of their workload does require a little bit denser storage, that's when I3N works for them. But now when they do the processing and they're able to move the data off, take a look at this example. When after they're done with the processing, they move the data off to S3 storage. So I'm going to just walk you through this flowchart again for their requirement, as we saw earlier. What do we have? They want high IOPS. They want microsecond level latency. What is that guiding us to is the instant store. And that's when I mentioned the I4I and I4G is the right choice for them. And for the denser storage, I3N is the right choice for them. And also what we heard about, they are self-managing the data copy, thereby moving it off to S3. And that's why the instant store is the right choice for them. Let's take a look at the other customer example. This one is a company, a retail company. And this example talks about they need very high IOPS, throughput, sub-millisecond latency for an e-commerce platform. They're running a commercial database on AWS. They also have a very specific need that they need to continuously scale their business with the growing customer needs. And they want the infrastructure to be flexible as well. You might be hearing some keywords here, flexibility, right? And they also need to regularly back up their crucial database to keep a copy of their customer entitlements, profiles, etc. Now, we got the requirements very clear. And it's actually good if you can identify your performance requirement in terms of some numbers. Here, we got 100,000 IOPS, 2 to 4 gigabyte per second of a throughput, and some millisecond latency. So having that precise requirement ahead of us it helps us really well to choose which block storage to go for. And they also require data persistence, frequent backup. Let's map it to the flowchart again. This flowchart is going to be very handy for you anytime you're looking at these and you have the requirements laid out. It will be very easy to walk through this. So now, given their requirements, both the instance store or the EBS store, both can work for 100,000 IOPS, 2 to 4 gigabyte per second throughput, some millisecond latency. But let's go deeper. Next step, what else they needed? They needed data persistency. They also need to do regular backups. EBS, that's the right choice for them because they also need to scale. They can scale anytime they want. Anytime they need more storage, they can add whatever amount of storage they want to add. And they can pay as they go with the storage. So EBS is the right choice here. So you saw how we navigated and we actually eliminated the instance store because clearly there are some key requirements here which are navigating us towards the elastic block store. Let's take a look at the third example. This is a customer, a real estate example. They need high performance, low latency. They also have dense storage need. And they clearly called out their workloads are Splunk indexing workload. They also have a PostgreSQL workload. But the requirements for both of these workloads were different. The Splunk indexing workload was the denser storage requirement, but still with the high performance and low latency. And part of this workload, which is the PostgreSQL workload, that was mission critical for them. For that workload, they needed data persistence for dealing with any kind of failure scenarios. Now, what are the choices for them? Let's go back to the flowchart again. They have a need for high performance, dense storage, some millisecond latency. That points to the instance store. They also have the data persistency requirement for the other workload. Where do we get the data persistency? Unless they manage it themselves, some way they can also do self-manage in terms of having 2 instance copies across AZs. They can manage that resiliency themselves, as we talked about in the data persistency slide. They have both the choices available for them. Now, as you saw, they have 2 separate workloads with different needs. For them, both of these solutions are the right solutions for them. And since they have the dense storage need for the Splunk indexing workload, but still high performance, that goes to instance store. And that's where you will think of the low cost per terabyte denser storage option, which is i3n, or IM4GN, or IS4GEN, depending on how much storage per VCP you need. But for the data persistency, they wanted not to manage it by themselves. They looked at, and they also, at this point, they're also comparing the prices, right? And they're also comparing the performance. Key thing is to also test. After you made your choices here, how would you know this is the right thing for you? That's when you do a POC. You have to test and see whether that performance level is adequate for your workloads. Now, you saw all the flow chart and how to guide and how to really walk through the simple steps to figure out what is the right solution. This is just a simple table for you to take a look at everything in one shot and look at the comparison. How do all of these options compare to each other? These are the different attributes and characteristics down to throughput, performance, latency, and the data resiliency, and all the other storage features level. But again, as I said, the key thing is to test. That's when you will know what is the right one for me. So this presentation, although you saw all the table comparison before, it's also going to be available with the recording on YouTube, as well as the slides will be shared on the Amazon page with the reInvent slides recording. But also, as I mentioned earlier, there are other sessions happening. One is the Chalk Talk session that I'll be doing later this afternoon. That's where we're going to go deeper into the local instance store. Within those 5 instance stores, What kind of combinations work for you? What type of cluster sizing work for you? How do you really optimize your workload to manipulate what is the best price performance I can get out of these available choices? That's what I would be talking about there. The other session that's happening with Amazon EBS and the differentiated performance with databases, Aaron will be covering that in another session this afternoon, I think, and as well as tomorrow. So there are 2 sessions for that. So please make sure to check out those sessions. And last but not least, I'll leave you up with some of these resources. Feel free to take a picture or scan these QR codes to learn more about the I4I, I4G instances, or the Elastic Block Store. And there is plenty of information available on Amazon website as well to learn more about these. And I'm sure you probably have been seeing this slide multiple times already about the Compute Digital Badge, the Digital Knowledge Badge. So I probably don't want to bore you to death about this. So hopefully you learned what you wanted to learn. Hopefully we achieved the goal for today, to walk away with the clear choices, with the clear guidelines in terms of how to choose the right block storage for your workloads, what is right for your business needs, how do you navigate from multiple instance types, and as well as what type of the block storage is the right choice for you. And with that, I'm sure you will want to probably ask any more questions. We can open up for more questions. And thank you for your time today. Feel free to fill up the evaluation form as well.